All right. So now I've got this going. So I want to calculate the greatest common divisor, or greatest common denominator is the way I was taught way back when what it was called, but the greatest common divisor of two numbers. So it's the number that's largest that divides both of them. So greatest common divisor of 20 and 15, it's 5, right? 5 is the biggest number that divides both of them. 10 will divide this guy, but not this guy. 5 is the biggest number. It's not the only number, right? 1 divides both these guys, but 5's bigger. Similarly with 36 and 24, 24 is it divides this cleanly twice and this cleanly 3 times, right? These are both multiples of 12. 12. The greatest common divisor is 12. The greatest common divisor of 38 and 18 is 2. They're both even numbers and they don't have any other factors in common, right? We're looking for the largest common factor, essentially. And the greatest common divisor of 17 and 97 is 1. So, how do we find such a thing? Well, we have a wonderful recursive algorithm. Given two positive integers m and m is greater than m. If n is a divisor of m, GCD mn is equal to n. Else is GCD mn is GCD of n mod n m mod n. Got that? No, of course not, because, okay, mathematicians really bug me when they use m and n as freaking variables. They sound the same when it's depending on the professor. Most professors, in fact, Not only that, it doesn't really make too much sense, right? Because, of course, you're totally familiar with how modular arithmetic works. But it's actually a fairly straightforward algorithm to write. So I'll write it, and then I'll show you how this works, right? But I'm going to write it in a bit more of a clear manner. Okay? So let's go ahead and take a look at this. Okay, public. Now this is an algorithm, famous algorithm called the Euclidean Algorithm, by the way. For something, for once, not named after Euler, but might get them confused since they both start with EU. So it's going to return an int because explicitly it's an integer, GCD. Now it had, right, m and int n, but it says given two integers, m is bigger than n. So we're just going to call them bigger and smaller, right? All right. And the other thing that we should probably do is, enforce that bigger is always the bigger number and smaller is not the small, and smaller is the smaller number, which is actually fairly easy to do, right? Because it doesn't really matter what order we're trying to figure out. The greatest common denominator of 36 and 24 is 12, and the greatest common denominator of 24 and 36, right, the same thing but reversed, should be the same, 12. So, GCD. So, if bigger is greater than smaller, if bigger is greater than smaller, what do we do? We should, if bigger is less than smaller, right? If it's smaller. If bigger is actually the smaller number, then we are just going to flip them, return, and we're not even going to bother swapping them. We're just going to be lazy about this and call greatest common denominator on smaller and bigger, which will do the same thing. They'll just swap it for us. Right? It's a recursive way to solve this problem where we could just swap those numbers. Okay, but I'm just trying. The big thing about recursion is that you're making every decision a local decision. So how do we know if so let's think of a base case, right? The base case here is if bigger is evenly divisible by smaller, which is simply saying that so if we can take bigger, divide it by smaller, and we don't have a remainder, then congratulations, we have a number that's evenly divisible by another number, which means that smaller is the greatest common factor between these guys. right? So bigger is small. So if we've got, so for instance, if we've got 10 and 5, 10 mod 5 is equal to 0, return smaller, right? We would return 5. Okay, but what if we end up with something like 12 and, what about, 12 is actually a terrible example. What about that example of 36 and 24? 36 mod 24 doesn't really work. So in that case, what we're going to do is, and you know what? I'll be explicit about it even though we don't need to. Else if, else. Return smaller. Return greatest common denominator of smaller. Okay, that's weird. And let's see. Greater or bigger mod smaller snacker. You try typing with a microphone like literally in front of you, in between your keyboard. It gets a bit difficult sometimes. Okay, so how does this work? Well, let's take a look at some examples of maybe, let's go ahead and try that. Oh, what was it? What's a good one? Let's do that 36. And I'm just going to go big, small, and big mod small. Because notice that we use that a lot. Big, small, big mod small. All right, so over here, let's give our example of, say, 36 again, 24. So what is big mod small? That gives us 12. Big mod small, right? 36 divided by 24 gives you a remainder of 12. Now we go on. What we do is that we run, okay, that this doesn't work. So instead we return smaller, bigger mod smaller. So 24 and 12. Is that evenly divisible? Yes, it is. So we're going to return small as our answer, and then this will return small as our answer. All right. So let's take a look at something like 38 and 18. So 38 mod 18. So what does 38 divide by 18? 38 gives you, so 18 times 2 gives us 36. So in other words, our remainder here is 2. Over here now, we've got 18 and 2. 2 goes into 18 perfectly, so boom. We return 2 in that case. Okay, so what was another one we had over here? 17 and 97. Okay, we had 17 as big and 97 as small, right? Which means that we actually flipped that around according to our algorithm, 97 and 17, so that we actually have something to work with. Okay. Let's go ahead and bring up a calculator here because I'm not going to do that in my head. 97 divided by 17 gives us 5.7. So what is 5 times 17? That gives us 85. So what we're looking at is the remainder of 90. So the remainder would be 97 minus 85. Don't understand how I got that. It's because, right, what is the biggest number we can multiply 17 by to figure out how many times we can subtract 97 from, or 17 from 97. That's what division is asking. How many times can I subtract this from 97? Could do it 5 times, and it says I could do that 5.7 times. Well, I just want the 5, and then I'd have 12 left over as the remainder. Okay. Now, now we have 17. So now we're going down. 17, 12 was 17 mod 12. 15, or rather 5. That's the difference there. And now we have 12, 5. 5 does not go into 12. So what is 12 mod 5? 2. 5, 2 gives us remainder 1. 2, 1. Everything's divisible by 1, right? If they don't share a common divisor, then eventually you're going to get into this end state where you have something divided by 1 or something mod 1, which is always true. Let's go ahead and test this. GCD 1797, right? Here we've got it, so even though we have bigger and smaller labeled, we can assume that the user might mess up at some point. 38, 18, and let's see, 20 and 15. Should be 5 in that case, right? Now, how is this a recursive function, right? Where we've got our base case, we have this, we're calling this, but we're calling it on a smaller problem, right? And each time it makes progress towards the base case, just because we're doing bigger mod a smaller number, so that is going to result in a smaller number than smaller over here, and a smaller number than bigger over here. So they're going to keep getting smaller until we get an answer.